Astrophotometry log, May 13th, 2009. It's approximately 5:17 UTC. I wanted to go over the last two earthquake predictions in the context of the data that came in during the prediction times. On the 28th, I noted that there might be a quake in the magnitude of near 6.5 above 15 north latitude. The largest quake during the period was a 6.2 in magnitude west of Guatemala City in Guatemala. I hadn't originally suspected that California would be the hypersymmetric location for that particular event. In astrophotometry, the movement happens on the subatomic level, so the movement was present, and so the probability for a very large earthquake in the area was a lot higher. But the largest one that was seen was in Los Angeles. It was a 4.2 on May 8th, and I think that this event could have been much larger if the X-ray activity that was associated with this either had been completely absent or came in one spike, like the warm finger effect. The higher frequency energy sort of loosens things and keeps it from snapping in the core weather model. And what we saw was a lot of little events rather than a big snap. And so this is a good thing, but at the same time, the core weather model indicates that this Pacific plate is actually welded from the extended solar minimum. And this higher energy that arrived before the quake, this X-ray activity that arrived before this 4.2 quake, probably kept this event from being much larger. These are the active regions on the sun that were responsible for producing those very tiny flares. If those flares had been much larger, this probably would have been what I call one of the warm finger effect quakes. And unfortunately, because of all this movement that has happened on the subatomic level, the likelihood of one of those warm finger events that are so hard to predict has increased. I'm suspecting that during this period, the level of radioactive gas such as radon in the ground probably increased because of the nature of the hypertime translation. There's an outstanding quake for this area now, and it could come with the arrival of a moderately sized flare from an active region. We're overdue, like I've said before, for the solar cycle beginning again, and so it's only a matter of time before we see that type of event. On May 5th, I had made a log that another coronal hole was going to be associated with an equatorial earthquake that I suspected would be up to 7.3 in magnitude. It was a very large coronal hole, and again, before the hypersymmetric movement was complete from that event, we saw this higher frequency energy that in theory loosened the tensile strength that made the ground theoretically more flexible. The hypersymmetric activity from that event happened nearly my first guess, a 6.1 off the coast of Ecuador, and this region had a significant amount of earthquake activity that I believe is the hypersymmetric movement, and I believe this is the hypersymmetric mapping of that particular coronal hole. But again, right before this event, there was this higher frequency energy. So this is one of the issues with the model right now. There's no way to know after we see the hole whether or not the X-ray curve is going to increase. If it increases slowly as it did before these two events, it lessens the impact of the earthquakes. It lessens the potential for the Earth to move all in one piece rather than moving in little pieces. It moves in little pieces when it's associated when the event is associated with an increase in the higher frequency energy, as well as the disturbance in the common carrier. The concept is that the common carrier is being disturbed when the translation through hypertime is inconsistent, and so it's that inconsistency that shows up as the hole in the corona, which is actually an out of phase relationship with the higher frequency energy, or a disturbance in the movement of the particular place on the Earth through time. This is not simple stuff to analyze, but all of the observations that I've seen that are associated with these two events are completely consistent with the model. These last two predictions have been the least successful of the predictions that I've done. I don't think that they're complete failures at all. And considering the data in context, I think that it's an incredible opportunity to learn and modify the process a little bit.